This lecture is on energy, work, and power. Energy is defined as the capacity to do work, and there are several forms of energy such as kinetic, potential, thermal, chemical, and electrical. Kinetic energy is the energy of motion. An object in motion has kinetic energy proportional to its mass and the square of its velocity. So the formula for kinetic energy is 1/2 mv squared. Potential energy is the energy stored in an object due to its position or configuration. The formula for potential energy is Pe equals mgh. For example, gravitational potential energy depends on an object's height and mass. Next form of energy is thermal, which is the energy associated with the random motion of atoms and molecules in a substance. It is related to temperature. So when temperature increases, the thermal energy also increases. Next form of energy is chemical, and it is the energy stored in chemical bonds released or absorbed during chemical reactions. Another form of energy is electrical energy, which is the energy associated with electric charges and their movement through a conductor. And also we have nuclear energy, which is the energy stored in the nucleus of an atom released during nuclear reactions such as fission or fusion. Units of energy. The SI unit of energy is the joule, and that is the amount of work done when a force of 1 Newton moves an object 1 meter. So 1 joule equals 1 Newton meter. Also, there are other units of energy, which include calories, kilowatt hours, and electron volts. Conservation of energy. It states that energy cannot be created or destroyed. It can only be transformed from one form to another. Let's look at some examples here. In mechanical systems, in a roller coaster, potential energy is converted to kinetic energy as the coaster descends. In electrical systems, in a battery-powered device, chemical energy is converted to electrical energy to power the device. And also in thermodynamics, in a steam engine, thermal energy from steam is converted to mechanical work. Definition of work. It is the process of energy transfer that occurs when a force is applied to an object, causing it to move over a distance. It quantifies the amount of energy transferred by the force to the object. The formula for work is W equals F times D times cosine theta, in which W is the work done measured in joules, F is the magnitude of the applied force measured in newtons, D is the displacement of the object in the direction of the force measured in meters, and theta is the angle between the force vector and the direction of displacement. Units of work. The SI unit of work is the joule. 1 joule is equivalent to 1 Newton of force causing a displacement of 1 meter. So 1 joule is 1 Newton meter. And there are positive and negative work. Work is considered positive when the force and displacement are in the same direction. So for example, if this person is lifting up this object Since the force and displacement are in the same direction, that work is positive. Work is negative when the force and displacement are in opposite directions. For example, the force of gravity is in the opposite direction compared with the case that this person lifts up this object. So the work of gravity on this object is negative. Some examples of work. Lifting an object. When lifting a weight vertically, the work done is equal to the force exerted equal to the object's weight times the height it is lifted. So W is mgh, in which m is the mass, g is the gravitational acceleration, which is 9.81 meters per second squared, and h is the height. Another example of work is pushing a cart. When pushing a shopping cart along a horizontal surface, the work done is the force applied times the distance moved. Power. It is defined as the rate at which work is done, or the rate at which energy is transferred or converted. And it quantifies how quickly work is performed or how fast energy is used over time. The formula for power is P equals W divided by T, in which P is power measured in watts, W is work done or energy transferred measured in joules, and T is time taken measured in seconds. Units of power. This I unit of power is the watt, and 1 watt is equivalent to 1 joule of work done or energy transferred per second. Also, there are other units of power, like horsepower, which is commonly used for engines. Kilowatts are also used, especially in electrical contexts. Examples are light bulb. A 60-watt light bulb uses 60 joules of energy per second. And a car engine rated at 100 horsepower can perform work at the rate of 74,600 watts. Let's work on some examples. Question number 1. A car with a mass of 1,500 kilograms is traveling at a speed of 20 meters per second. What is its kinetic energy? Okay, so the formula that we have to use here is kinetic energy equals 1/2 times mv squared. So as we plug in the numbers, m, which is the mass of the object or the car, is 1,500 kilograms times the speed to the power of 2. So it becomes 1/2 times 1,500 times 20 squared, which is equal to 300,000 joules. Next question is, a 10-kilogram object is lifted to a height of 5 meters. What is the gravitational potential energy? So the formula that we have to use is potential energy equals mgh. So as we plug in the numbers, the mass of the object is 10 kilograms, g is 9.81 meters per second squared, and the height is 5 meters. So as we multiply these numbers, we get PE, which is the potential energy of the object, equals 490 joules. Next question is, a person applies a force of 50 newtons to push a box across the floor. The force is applied at an angle of 30 degrees to the horizontal, and the box moves 10 meters. How much work is done by the person? Okay, so the formula that we have to use here is W, which is work, equals FD cosine theta. So as we plug in the numbers, we know that the force applied was 50 newtons, displacement was 10 meters, multiplied by cosine theta, and the question says that the angle of the force applied to the horizontal is 30 degrees. So you multiply that by cosine 30, and finally we get the answer as 433 joules. Next question is, a person pushes a shopping cart with a force of 80 newtons horizontally for a distance of 15 meters. How much work is done on the shopping cart? Okay, the formula is W equals FD cosine theta. So as we plug in the numbers, W equals 80, which was the force, times 15, which was the distance, times cosine 0, because the force was applied horizontally, and cosine 0 degrees is equal to 1. Therefore, if you multiply these two numbers, we get 1200 joules. Next question. A machine does 2000 joules of work in 10 seconds. What is the power output of the machine? So the formula for power is P equals W divided by T. Therefore, plugging in the numbers, P equals 2000 divided by 10, in which 2000 is the amount of work done and 10 is the time. So 2000 divided by 10 equals 200 watts. Next question. A person lifts a 50 kilogram box to a height of 3 meters in 5 seconds. What is the power output of the person? So in this question, the amount of work is not given to us. So we have to calculate that first. W, which is work, equals mgh. Therefore, W equals 50, which is the mass, times 9.81, which is g, times 3, which is the height. So the work equals 1470 joules. In the next step, we have to divide the amount of work by time, which is given as 5 seconds, to get the power. So plugging in these numbers, P equals 1470 divided by 5 equals 294 watts.